Hey, hi! Ever wondered what you could do with an empty water bottle? Well, here's an idea. How about make a submarine out of it? Interesting, right? Hi, my name is Izzat Farhan, and together with my team, Fatini, Razak, Hismori, and Irham, we are going to build a submarine using PET bottle.
Our aim is to help spread awareness of recycling of PET bottles and implement the use of recycled materials in classroom for educational purposes. We believe that the lifespan of a PET bottle does not end after being used as a container for consumable liquids, but rather can be put in better use. The objective for this project is to show how some basic principles of physics are applied in modern and complex machinery, such as the submarine, and it is also to promote creative thinking in youth and enlarging the limits of resources by using waste materials such as PET bottles. Last one is to educate and encourage students to reuse, reduce, and also recycle. Modern-day submarines are commonly made of high-strength alloyed steel and titanium to withstand corrosion and avoid oxidizing reaction. Submarines are underwater self-propelled crafts that are designed and built to perform underwater operations. We decided on creating a submarine out of recycled waste because it's a resource which is more convenient and easy to obtain, thus encouraging students to start making one without the need of complex and expensive resources. Apart from that, this project also focuses on creating a product that obeys the principle of engineering where students can greatly benefit from. The rising number of using PET bottles has raised concerns to us all due to its effect on the environment and how long it takes to degrade naturally. The decrease in interest towards engineering is because of so many engineering institutions, which makes engineering lose its value. The educational system is failing to instill a sense of creativity in students, rather they are being trained to solely focus on achieving good grades. This fish submarine is made of two different sized mineral bottles, where the larger 1.5 liter is the shell of the fish submarine and the smaller 250 ml is used as the housing for all the electronics. Its estimated length is 40 cm with a width of 10 cm. One of the key highlights for this fish submarine is that it uses its tail to change its direction, and it's also equipped with functional LED lights on its head. It also has its own ballast tank made by using a syringe. How does this fish submarine works? Well, the submarine is controlled by using a controller. The controller sends a radio wave through the receiver in the submarine. The receiver then picks up the signal and decodes them. Each button on the controller corresponds to a specific axis of direction to move the submarine. 3 DC motors are used to control the movement, where each of them are assigned to a specific role on the submarine. One of them are attached to the propellers to control the forward and backward movement. The tail of the submarine is attached via a shaft to a second motor to redirect the flow of water produced from the propeller. The last motor is attached directly to the syringe, which it acts as a ballast tank to regulate the density of the submarine. These are some comparison with a product on the market. This product is made of non-recycled plastic, which is not an environmentally friendly considering the amount of plastic waste on the planet. Referring to the price, we can see that it is also pricey when comparing to making it yourself. The product is also pre-assembled and tightly sealed, which avoids curiosity of students from knowing how it works. Compared to our product, our submarine is much simpler and easier to understand with attractive design concept. Some of the materials used in this project are a 6 ml syringe, 3 12 DC brushed motor, 1 remote controller, few copper wires, a receiver board, and a propeller, which total up to a cost of 50 ringgit. Some of the 5 applied courses are fluid mechanics, because submarines comply with certain fluid laws of nature in order to travel underwater, including the theory of Archimedes and rule of Boyle's, introduction to electrical and electronic engineering, the uses of battery motor receiver, and to learn how long the submarine can operate underwater and how much power is needed to run the component. Analysis of mechanical component to know whether the component is suitable for the conditions underwater so that the submarine does not run into any failures while operating. The fourth one is a material selection and performance. Develop a submarine at low cost which uses recycled waste for an educational kit. Last but not least, engineering dynamics. How to redirect the flow of water steadily so that it will be able to navigate underwater easily.